Okay, we're going to be looking at the Unit 6 review for the exam tomorrow. I'm going to move some stuff around here. And I'm not, of course, going to work all of these questions because this would be the longest video ever and nobody wants to watch that many minutes of math in a row. So we're going to do just a few here and there so we can make sure that you are ready to go for this test tomorrow. So this test is all about angle relationships and making sure that we know that there are four big unit relationships, two angles that add to 90, two angles that add to 180, two angles that add to 360, and then two angles that are congruent to each other, equal to each other. Okay? But first, let's talk about a couple of these throwback questions. So these are segment addition questions. I hope you recognized them when you saw them. And so when we look at segment addition, we should sort of really quickly see that QR plus ST, that's crazy, QR plus RS is equal to QS. Okay, and so we can set up this equation based on what we know about segment addition, right? So we know that QR is x plus 2, and we know that RS is 7, and we know that the entire segment is 2x minus 1. So this is the same part plus part equals whole. So QR is x plus 2, and RS is 7, and it's going to equal QS, which is 2x minus 1. Okay? And then we can solve this, and we're just solving for x in this case, and this is important to note. You always want to look to see what you're solving for. Just x in this case. So we combine like terms here, then 2 plus 7 would be x plus 9 is equal to 2x minus 1. And then I usually will put the x's together next, so I'm going to subtract x from each side of this equation. And 9 is going to equal x minus 1. And then I'm going to add 1. I'm going to run out of room here. I better work on this. And I'm going to get that x is equal to 10. Okay? So these first few questions, they're all pretty much the same segment addition type question. The only difference is for the next ones, so that 2 is exactly the same, but for 3 and 4, instead of finding x, you're actually finding a segment length. So let's look at 4 really quick. So same thing here. We have ST plus TU is going to be equal to SU, the entire thing. Okay, so I'm going to kind of come up here. We can say ST, which is 2x plus 26, plus TU, which is 4, is equal to x plus 21. So part plus part equals whole. Okay, and then we can combine like terms over here. We get 2x plus 30 is equal to x plus 21. And then we're going to put the x's together, and we're going across the equal sign, so I'm subtracting x from each side. And I'm getting 2x minus 1x, it's just an old plain old 1x, plus 30 is equal to 21. And then I'm going to put the numbers together, so I'm going to subtract 30 from each side. And I'm going to get x is equal to what looks like negative 9. And I'm going a little fast here, I'm not really checking as I'm going, so if I make a careless mistake, you can yell at me tomorrow. All right, so that's x, but actually it wants us to find ST, right? So ST can be found by taking 2 times x plus 26, 2 times x plus 26. So we just found that x is negative 9, so we're going to say 2 times negative 9 plus 26, or 18 plus 26, which would be 8, I believe. So this particular line segment would be 8 units long, or if I mess that up, whatever negative 18 plus 26 is. All right, so that's your throwback questions. Let's move on. I'm taking a little too long here. I'm going to speed this up. So the next one says measure of each angle to the nearest 10 degrees. And so what I would notice about this is it's really close It's really, really close to 90 degrees, but actually just slightly less than 90. And so I'd say, okay, well, it's maybe 80 degrees then, because it's just slightly less than 90. And that is how I would think about it. So I'd do 6 pretty similarly. I would say, oh, it's really, 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 really close to 180 degrees, right? Which would be a whole line, right? So 180 is an entire line, and we're saying, okay, but what's actually slightly less than that? So what's slightly less than 180? I might say something like 170 degrees is slightly less than 180, or 175, or 165. Okay, so you're just kind of estimating, what does it look like? How big do you think it is? All right, the next set, you're looking at the angles, and I don't have an obtuse one here. I'm seeing pretty sad about that, but acute angles are less than 90. Obtuse angles are greater than 90, but less than 180. Right angles are equal to 90, and straight angles are equal to 180. So that's kind of what you remember here. And each one of these is course degrees. So this guy right here, even though we're not seeing the square, we could maybe measure it. It looks like it's maybe 90 degrees, so we would call this right. Okay. And this guy right here, well, this would be 90 degrees, and it's less than 90. So I said this would be 90 degrees, and it's actually less than 90, so we would call that acute. And then 180, we would call that a straight angle. And 90, we would call that a right angle. Okay. Next set of questions, a little quick vocabulary here. It says name the vertex. So the vertex is right here at point S. And then it says name the sides as well. So we have a ray that is ST, that is a side. And then we have a ray that is SR, that is a side. Okay, so that's how you would name them. And then the next question says name in 4 ways. So we can name this in 4 ways. We can name it with its number. We can say this is angle 2. We can name it with its vertex. We can say this is angle H. We can name it from left to right, making sure the vertex is in the middle, angle IHG.